slope-intercept form. It's our third method of graphing a line. What we just discovered is that slope-intercept form is the same thing as function form. It's just like those function rules that we were trying to write earlier in this unit. Y equals mx plus b. When we were finding b, the number at the end of this equation, what we were discovering is the y-intercept. The number that goes in place of b will always be the y-intercept as long as the equation is written in function form or slope-intercept form. The number that goes in place of m, that fraction that we were discovering, that is always going to be our slope as long as the equation is in function or slope-intercept form. The number in front of the x, the number that replaces m, will always be our slope. Remember, slope is the steepness of a line. It determines how steep it is. Is it close to flat? Is it very, very steep? That's determined by that number in place of m. So let's look at some equations in function or slope-intercept form. The name slope-intercept is exactly what the numbers in the equation give us. The first number is our slope. The second number is our y-intercept. So when we graph a line in slope-intercept form, we don't have to make a table. We don't need to find the intercepts by plugging in 0. We simply use the two pieces of information given to us in the equation. Let's look at line A. It says in line A that we have a y-intercept of -6. So remember, on a graph, the vertical axis is y and the horizontal is x. So let's go on our y-axis. Let's go down to -6 and let's plot ourselves a point. Then we have our slope. Remember, slope determines how steep that a line is. The way that I can think about that steepness is rise over run. How far do I rise and do I run from point to point on that line? Well, this slope is 2/3, so that means I rise 2. So I'm going to count up 2 boxes from that dot, and then I'm going to count over 3, and I'm going to put my next point. Let's do that one more time. Count up 2 boxes and over 3, and I have my next point. When I connect those, I have my line, and you see that rise and run created the steepness. By going up 2 and over 3, it gave that line a little bit of steepness. It's not very steep, but it does have some steepness. It's not flat. Now, let's look at line B. Line B has a y-intercept of 8, so that's our starting point. We're going to go to 8 on the y-axis and put our first point. Then our slope is -2. Now remember, slope is rise over run. I really would like a fraction there, so I'm going to make -2 into a fraction by making it -2 over 1. Now, my rise over my run is -2 over 1. Now let's use our common sense. Can we rise 2 spaces? No, right? It doesn't make sense to rise -2. So we are going to go down 2. We're going to go down 2 spaces from our original dot. So 1, 2. And then we're going to go over 1. We're going to repeat that process again to make our line. We're going to go down 2 and over 1. Generally speaking, I make 3 dots and connect them, but you could continue because remember, in a function, that pattern goes on for forever. So I could continue making dots for as long as I wanted. I'm going to connect my dots, remembering to put my arrows on either end to show that that line goes on for forever. And now I have graphed line B. So graphing a line in slope-intercept form simply means using the y-intercept as my starting point and using the slope to graph a few extra points and then connecting those points to make the line. Now, I want you to try graphing these 3 lines by using the slope and the y-intercept. Once you have finished, then I want you to submit your notes to Seesaw.